Now that we've learned how to set up all of our data tables whenever all of our measurements are direct, let's look at what we need to do if one of our measurements is indirect. Now, this question, how does the height a marble is dropped from on a ramp affect its velocity at the bottom? So here's my ramp again, and instead of looking at how long it takes to go across that 1 meter down there, let's look at how fast it's going whenever it hits that bottom area. Now, velocity, speed would be the scalar version of that, isn't something that I can measure directly. This is an indirect measurement. I have to calculate that velocity equals displacement over time, unless you happen to have a teeny radar gun or you know how to do video analysis on that marble. The initial thing is it's an indirect measurement. You actually need to calculate that. Now I can go ahead and set up all my data tables. I have my graphing table, right, where my independent variable is drop height, and then my dependent variable in the y position here is my average velocity. Now my goal here to actually fill in my graphing table so that I have a graph and I can examine that data and draw conclusions. I already know my drop heights, right, because I choose them. They're my independent variables, so I already have those, but I don't know my average velocity. That's what the point of the lab is, the dependent variable. To find my average velocity, though, I actually need to divide displacement divided by time. So I need what's called a calculations table, where I'm going to record all the displacements for each trial, and then I'm going to have my times. But of course, displacement's easy to set. Let's just set our displacement to be 1 meter and time how long it takes for the marble to cross that. And then I'll take my 1 meter and divide it by time and I get velocity. But of course, I need to do 5 repetitions of this. So I need to time it 5 different times, come out with an average time for each one, and then take that average time and drop it down here. So these are my 5 trials for each height. I should have marked out that this was for the 0.1 and the 0.2 meters and 0.3, 0.4, 0.5 meters. So whenever I drop my average times down, then I could calculate my average velocity. So let's go about doing the lab at the exact same way, and so that we can have all of our times. Great, now I have all my raw data and all my uncertainties applied to the averages. Now let me back up for a second, just for clarity's sake and to re-emphasize a point. After you have your procedures, before you even come in and begin to collect data, go ahead and set up all your raw data tables. I actually recommend that you start out by skipping a decent amount of space and putting in your graphing table down here. The reason that I recommend that is the graphing table is the easiest one to draw out. You need 5 spots for your independent variable, and you know what your independent variable is from your question. And then you need 5 spots next to that for your dependent variable, and you know what your dependent variable is from your question also. Now, your independent variable will be very easy to fill in because you can look back at your procedures and you actually have already chosen what all of those numbers will be. Then look at your dependent variable and just ask, what do I need to do to get there? Is all I have to do, because it's a direct measurement, just go and measure it a bunch of times? If so, all you need is a raw data table, and you'll come out to your dependent variable because you're just going to measure it a whole bunch of times over here, 5 times at minimum. You'll average it, and then you'll actually have your dependent variable. On the other hand, like in this case, if you look at your dependent variable, right, in your question or in the second column of your graphing table, and you recognize that it is something you have to calculate, it's something that depends upon all your other raw measurements. It's an indirect measurement. Then you're going to need a calculations table. Think to yourself, what do I need in the calculation? Velocity is displacement divided by time if we assume that it's moving at a constant velocity here. So I need a displacement and I need times. And which would be easiest to measure? Well, if I set my displacement to be constant, 1 meter for each one, maybe make that a control variable there, so 1 meter each time, then I'll measure the time it takes to go across whenever I drop it from each height, and then I can take my displacement and divide it by my times to get my average velocities. So now I can copy over my average times, and that'll allow me to go ahead and calculate all of my average velocities, doing my displacements divided by my times for each individual height, the 0.1, the 0.2, the 0.3, where I was dropping it from. Note that the height that I dropped it from is not the displacement that I let it go across, so never get those confused. Sometimes your independent variable and things you need to use in your calculations table are completely different. So anyway, calculate the velocities. Make sure to show one example calculation. I just chose the first one here, and label it well. Show that example calculation either off to the side or right below that calculations table. And now that I've done all my uncertainty calculations, propagated my error in there, if you need to look back at how to propagate error, or if you need to do that, then check out the propagating error video. I now have my average velocities that I can move over into my graphing table. And now I have everything ready for me to go ahead and put it on a graph. Remember that your independent variable here is your x-axis, your dependent variable here is your y-axis. All of your uncertainties end up being your error bars.